So this is in continuation with the non-deterministic finite automata's previous lecture. So let's look at another example of an NFA given below. This NFA has 4 states, Q0, Q1, Q2 and Q3, where Q2 is the final state, and as you can see by this arrow leading to Q0, this is the initial state. Q0 is the initial state. So we can go from Q0 with an A, if you look at this transition, to the state Q1, and from Q1, looking at this transition, we can reach Q2, which is the final state, with the B. So this depicts that the string AB is the shortest possible string from the start state to the first occurrence of the final state that is accepted. Now let's look at these lambda transitions. What do they do step by step? So this is the first lambda transition, which leads from Q2 to Q3, and the second lambda transition leads from Q3 back to Q0. So you can see this is making a cycle. So you go back to Q0 and then you can start over taking an A or a B again. So let's say this is your input example, input string, which is AB. Your tape head is not reading anything as yet, and you're at the state Q0. So you go forward, you read an A, you take this transition, and you go to reach Q1. Next, your tape head moves forward, it goes here, you're reading a B. So at state Q1, you have an outgoing edge with the input letter B, which leads to Q2. Q2 being the final state, it accepts the input string. Now let's say we have another string, which is not just AB, but it is AB followed by AB again. So start state, you are at Q0. Again, the same process will take you to the state Q2, but the string is not yet fully consumed. At this point, you have a lambda transition. You don't have a transition for A, you don't have a transition for B, but you do have a transition with lambda. And between this B and this A, there is nothing. And nothing is an indication that lambda is there. So lambda, we take lambda transition and we take move from Q2 to Q3, anticipating maybe there is another transition, or maybe we could read something from the string, but nevertheless we move. So we get to the state Q3. Sorry, we were here. So we have read, let me come back. So we are at the state Q0, we read the A, we then read B, we get to Q2, string's not yet ended. So we take this lambda transition, but we stay at the letter B. Now at Q3, still it's not the final state, but we have a lambda transition. So thinking that maybe we'll get something else, we take this lambda transition, go forward, get to the state Q0. Now we can move forward because we have a transition labeled with the input letter A, and the next letter at input is A, and the transition we have is A as well. So we take that, get to the state Q1. Again, the next input letter is a B, which is an outgoing edge at the state Q1. We take that transition and get to the state Q2. So that's the string is in this way accepted. So if you look at the pattern, so this seems something like the language, which is AB followed by another string which is AB AB, or AB AB AB. So basically the regular expression for the language would be AB whole plus, or you can write this as AB followed by another AB whole star, if you remember. So why do we avoid a plus? Okay. Now let's look at another example of an NFA. It is again an NFA lambda because we have a transition which leads from Q0 to Q2 directly. So this is our only final state. So let's look at the shortest possible path we can take to come back to this state. So the shortest possible way we can come back to this state Q0 is we take this transition, reach Q1 and then come back here. That would be the string 1 0. So the string would be 1 0. Before that, since our start state is also our final state, so that means without accepting anything, we are still at the final state. So absence of something means absence of anything at all means you have lambda in your language. So Q0 being the final state indicates that lambda is also one string in the language. Then let's go forward and see how this NFA works. So if you see the language given by this NFA lambda would be, so you have, since the start state is also the final state, you have lambda, then you have 1 0. You can take this 1 0 1 0 again. See, if you take this outgoing edge at Q1 state with either a 0 or a 1 and you get to Q2, there is no way you can come back to Q0. Similarly, if you go to state Q2, there again is no way you can come back to state Q0. So this doesn't really change the language. So this pattern, this cycle is what determines the language. Okay, the lambda symbol never appears on the input tape. Please note this. The input, if let's say this input we have previously, this input tape, this string that we are reading, this is the input tape. The way you give input at the keyboard, you are giving input of A, B, C, D, E, F, but you don't give the input which indicating that the next letter is nothing. So you just don't give an input at that point. So similarly, the lambda symbol, this was just for the sake of understanding, the lambda symbol never appears on the input tape. So look at these two automatas which given below, M1 and M2. You have a Q0 state in both. Here the language is the empty language. Here the language where the start state is also your final state. The language has this one string which is lambda. So basically, if you recall, we had a lecture related to the automated tap, which is sensing the presence of a hand. So it's something like that. So that was just for you to recall what lambda is. But now this is interesting, which you really have to remember, the difference between an NFA and a DFA. So NFAs are interesting because we can express languages in an easier way than in a DFA. DFAs have to be complete. DFAs have to be deterministic. And non-determinism allows us to not complete a machine in terms of every input letter. For example, this is a machine for the NFA M1. Please see that the language is A. Now at the state Q0, you have a transition which takes it to the state Q1. And that's about it. Please note that both for in this case here, our sigma is only one letter A. We don't have a B. So our sigma has only one alphabet, which is A. This is the corresponding NFA for the language which has one string only, which is A. This is the DFA for that. M2 is a DFA for that. But see, there is a huge difference. Here you have to give an outgoing edge for the letter which is A. So Q1, at the state Q1, in case of a DFA, you have to tell what happens if you get an A again. So you go to a state which is Q2, which is your dead state, which is your trap state, which just doesn't have a path coming back to the final state. Since our language has only one string, which is this A. So therefore, this is a basic difference between a DFA and an NFA. So there would be one more lecture on the difference between DFA and NFA. So you will be more clear in that. Formally defining NFA. So what we have similar to your DFA, we have, this is again a 5-tuple set. We have Q, which is your set of states. We have sigma, which is our input alphabet. Please ignore the spelling. You have delta, which is your transition function. You have Q naught, which is your initial state. F is a set of all the accepting or final states. Please note that our input alphabet sigma AB does not include lambda. Lambda is the absence of particular letter or both, either one or both of them. So transition function is what is different from a DFA. Please note that from any state Q with the input letter X, we may have more than one state that we are getting to. So from the state Q1, for example, or Q0, for example, for any Q state example, you are getting the letter A or X here, and you are reaching Q1, Q2, and let's say you have these K states that you can reach. This is not possible with the DFA. There is always one outgoing edge from a particular state against a particular letter. So resulting states here with following one transition with simple X. So I guess that's about it about NFA. You can go through the rest. These are some examples giving an explanation of your transition function. So here you can see the transition function states that at the state Q1, when you get a 0, you can go to the state Q0, and you can also go to the state Q2 with a 0. So this is the difference. You cannot have this in a DFA. In a DFA, you will have only one outgoing edge against a particular letter. Either you will have this edge or you will have this outgoing edge. That is it. So all the best.